Hey guys, let's try writing a good old factorial function in Python. This of course is one of the functions that we use to teach people about recursive functions. Normally you would do it in the way that I'm doing it here. We return 1 for n equals 0, that's our base case, and then we get to the climax where we write that sweet recursive line. There is so much zen in that one line. I'm a big fan of recursion, as you may have guessed by now. Let's start Python Interactive and import fact from playground. We test the cases n equals 10, 100 and 1000. Bummer, we ran out of stack depth for n equals 1000. Let's try something else then. Let's add an accumulator as an argument. Maybe this way the interpreter would know to not create a new stack frame in every recursive call. Let's test this now. Let's restart Python Interactive actually. What? Those of you coming from C++ or Java must be like, ain't it recursive though? So Guido van Rossum, the great creator of the great language we know as Python, feels that he would rather have a proper backtrace on exceptions, which would not be possible with tail call optimizations. So what do we do then? You can make use of the decorator design pattern to emulate tail call optimizations. A decorator is a function that takes a function as an argument and returns another function. Here for example, we take f as an argument, create g on the fly and return it. Now let's focus on what we're going to do in g. So we pass the arguments to f. Now we check if the result is of type tuple. If not, we just return the result. Otherwise, we just set the arguments on the next iteration to be the result tuple. Let's take a look if everything is okay. Then we come down here and change that recursive call to just be a tuple containing arguments to the next recursive call. So let's test this now. Actually, we need to decorate the fact function first. This kind of syntax is equivalent to setting fact equal to the result of applying tailrec on fact. Awesome. Just gonna check a few more biggies, but you get the idea. This is great, but there are two problems. First, what if the recursive function was supposed to return a tuple in the first place? Second, tail call optimization is not just for recursive calls, but any tail calls. Therefore, we need to further refine this. Alright, so let's first of all change tailrec to tail call. Now what we'll do is extract the first element of the result tuple. Then we check if the first element is a string and whether its length is greater than 1, otherwise we return result. So the format that we shall follow now is add func followed by arguments, where func is the function we want to make a tail call to, but before that we need to maintain a dictionary that stores the mapping from the function name to the function. Now that we know that first is a string, we check its format to see if it begins with at. Yay, so that works. And we should be able to make it work for any kind of tail call. To be honest though, I agree with the creator of Python. Backtraces are important, but besides you should not be using Python in the first place if memory optimization is so important to you. However, while solving problems on LeetCode and HackerRank, you may want to solve a problem recursively, but are held back by the max recursive depth. For that, you could keep this decorator in your arsenal when you don't have the time to refactor your code to make it iterative from recursive. Essentially, this decorator enables recursion with the iteration at its backend. Feel free to reach out to me at this email for any questions. Thank you.